So welcome to day 3 of our Intro to Android course. Last time we introduced you to storing and manipulating data in Java. If you did miss that module, if this is your first time here, welcome. We're happy to have you. And please go back and review that on our YouTube playlist. You're welcome to stay here tonight. It might be a little bit harder for you to follow if you don't have any programming experience, but if you do, you'll be able to do this just fine. If you don't have programming experience, it'll help you understand today's topics. It does seem like there were a few hiccups. After a few hiccups with Replit, many of you are able to finish the assignment from yesterday, but there are still a few more that have yet to submit it. So please do get to that as soon as you can and submit that so you can get some feedback on that and you can test your comprehension of yesterday's topics. I did notice a few things in reviewing the assignments that I wanted to cover and clarify. So I wanted to bring this up in a Android demo. We're not going to use the user interface at all. We're going to use some debug tools to test something. When we're using increment and decrement, what we'll want to do, just do a simple value. Increment and decrement will automatically store the value in that resource. So this isn't like, so this is equivalent to x plus 1. So these two lines do the same thing, effectively the same thing. So you don't need to store the value because the stored value will be stored by itself. And then we can see that if we do we can add a debug line right here. We can have that compile. I have my virtual machine running in the background. We don't need to see it because it's not doing anything yet. But it's going to go ahead and build, and this will also be a good demonstration on how you can use the debug tool in Android Studio. As soon as it's done, we'll let it go. I'll scratch my nose. There it goes. Installing APK, launching. There you go. There you go. So it launched, executed, and you remember from the first day, now this is blue, so execution is paused here. If we look here, we don't have an X variable. If we click this arrow down here, it'll step to the next line. And here we go. We just instantiated an X variable, a data member, X equals 0. And we're at this line. So let's execute that line. And now X is 1. See, we didn't have to store it. It just incremented it and stored it itself. That's one of the beauties of the increment operator versus the standard addition operator. So that does the same thing as, like I said before, if we go back, X equals X plus 1 is equivalent to this. And then same thing with the decrement operator. That's going to be equivalent. And it doesn't matter which side. It does for the increment and decrement, but they're both going to store the values. So I just wanted to show you that there. Make sure we had covered that properly. So let's move on. We're going to talk about today how we can manipulate the flow of execution through our code using conditionals and loops. So here are the objectives that we have for this module. So upon completion of this module, you'll be able to follow basic flowcharts, use relational operators to compare values, use if and else statements to control the flow of code, use a switch statement to allow for multiple possible outcomes, use Boolean operators to combine Boolean expressions, use ternary operators to choose one of two options, use a while loop to run code until a condition is met, and finally use a for loop to perform a task a specific number of times. So that's what we're going to be able to do here, and that's what the goal is. There are a lot of them, but we'll get to them, and they're pretty quick, each of those. We'll explain it, then we'll do a quick demo, and then we can move on to the next one. I also want to go over the assignment, touch on that. We're going to complete the Intro to Java assignment, which is similar to last night's. It's a series of exercises, but we have it in two forms. We have Replit, just like last night, but I also created a Google form. This is for graphical. We'll be using truth tables, and I'll show you how those work. But we'll be able to be able to fill those out graphically in Google Forms. And when you submit it, it'll send the values to me, and then I can have it automatically graded and sent back to you. I'll get that done in the morning for those of you that were able to submit it tonight. And then for the challenge, I want you to be able to practice performing similar tasks in Android. So the same thing, just doing the flow, the while loops and if statements and things like that in Android, kind of see how it does. And I'll demonstrate a few cool things that we can do with that today in Android. So first I want to introduce you to flowcharts. They're a fantastic tool for planning the logic of your app. You have different shapes that represent different things. And many of you have seen flowcharts, especially ones like this, that are kind of silly and show different things, but it's a good tool to be able to see that. And you can easily, people that don't even have any experience can easily see the flow of things. And we'll do that with flowcharts in code. So I wanted to show you an example of a code flowchart. This is for a project that I built a couple of years ago. It is what it does is it finds controllers, finds Wi-Fi enabled controllers on a network. So I'll step you through how this goes. So your code will start here at the top with this rounded rectangle. And then each of these boxes are a separate statement. So the first statement or first, since this is a higher level flowchart, meaning it's further away, like a high level language, it's a higher level flowchart. So it'll just tell kind of what the process does. It doesn't have to break it down line by line of code. So for example, this performs an ARP scan, which scans the network, and it'll return a list of IP addresses and MAC addresses. Then what we'll do is you see here we have it's like a statement, but it has these lines. This is a sub-process symbol. So what it tells us we can go into here and we check the addresses. So we go into the check addresses sub-process. We use this list that we got here, and we're going to do for each of these, we're doing a loop, just like we're going to go over later on. We're looping through it. We'll attempt to open a network communication with that to the device, that IP address. If it successfully responds, then we move on and add that to our validated list. If it doesn't, then we loop back and do it again to the next one. Once these are all done, we will return the list of validated IP addresses back to this method. Then we will load a separate list from a file. We will go through all of the values on that and mark them as inactive. And then what we're going to do is for each of the IP addresses that we validated here. So remember, we now have two lists. We have the one from the file and the one we validated here. We'll go through and we'll perform another sub-process, which is check controllers. Also, this is a good time to show you the way this is set up, this way this is named, it makes it seem like it's checking all of them at the same time, where in fact, since it's inside of the loop, it's only checking one at a time. So really what I should have done here is I should have named it check controller to make it clear that it's only going to check one. So we'll take our list and bring it here. We're comparing the two lists here. We're going to see if the values in the first list, if a value in the first list is in the second list. If it is, then we're going to check to see if the IP addresses from the old list and the new list match. If they don't, we will update the IP address. If they do, we will just mark that controller as active. If the controller isn't in the list, we're going to add it to the list, and then we'll return that list. There we go. We do that through the whole loop. Then we save our updated list, and we exit. So this is a good example of how a flowchart can be used to illustrate complex processes in simple terms that people can follow. So that's flowcharts. What I want to do now is I want to help you use relational operators to compare values. So let's go here. We'll go to the next one. Boolean expressions are statements that return a Boolean value. You remember Booleans from yesterday? A Boolean value is either true or false. That's it. Nothing else, true or false. So Boolean expressions will evaluate a statement and it will either be true or false. A Boolean expression can also just be a Boolean value. And these are used to determine the logical path of execution. We use relational operators to compare two values. and then Boolean operators to combine relational expressions for more complicated logic. And we'll go through each of those. So next, let's look at the relational operators. So you see here that this is our comparator operator. So remember, a single symbol is the assignment operator. Two of them makes the comparator. So you want to be very clear and separate about those. You want to pay extra close to the attention, because that can cause issues. If you think you're comparing, but you're actually assigning by only having one, then that can cause a lot of issues in your code that makes it hard to find. So you can see also many of these operators are reminiscent of their mathematical counterparts. We just combine two into a unary symbol because there's two symbols being one. And then two compared values would also be of comparable types. For example, you can't compare a string, which is a series of texts like we used in our buttons to name them. You can't compare that to an integer, but an integer can be compared to a float. So you want to make sure that you have values that are able to be compared to each other, because that's another source of issues. But you look here, this next one is with the exclamation point and the equal sign. This is not equivalent to. So it will return if you have 5 and a 6, it will turn true because 5 is not equivalent to 6. If it's 5 and 5, then it'll return false because 5 is equivalent to 5. And same thing, and so it's basically the opposite of this. These two are opposites. Now you have your greater than. So if the symbol on the left is greater than the one on the right, then it's true. Greater than or equal to, greater than, same thing, greater than or equal to, and then the less than are the opposite of those. So let's play around with a couple of those and we'll see the result of that. So let's bring up Replit. Let's get your hands on keyboards. I'll give you a minute to bring up a Replit window. And then I want you to type along with me so you can get experience kind of typing with these and build up your muscle memory. So we'll do a couple. If you're still getting Replit up, it's fine. So we're going to print the result out. We're not going to do anything else with it at this point. So let's do that. Let's do the example I was giving you. 5 is not equivalent to 6. Let's see what it does. So true because 5 is not equivalent to 6. If we were to change that to equivalent to, and we run that, it's false. But if we were to also change it to 5 is equivalent to 5, we're going to get true. And then another thing we can test is our less than. So 5 is less than or equal to 5. That's true. And then if we do 6 is less than or equal to 5, it's going to be false. So you can see it's simple to put these together. One thing you'll want to do is put your expressions in parentheses. In some situations, it's required. In others, it's just a good decision to make your code clearer and easier to understand. So now since you have your replets up, I have a challenge for you. This time we'll give you a little less time to do it than last time. But I want you to do two things. Create a variable called grade and assign it a value. Be any value that you want. And then I want you to write a line of code that prints true if the grade is high enough to pass the class. And you can determine that. And it'll print false if it's not high enough, and you can determine that threshold. So I'll give you 2 minutes to do that. It shouldn't be too bad, and then we'll go over the answer on that. I'll bring this window up here and start building that. Okay, we got 1 minute left. Okay, now let's go over the solution to that. So this is my solution. Yours might look slightly different. So you can see here we did the same thing we did last night. We're declaring the value as an int. You could use a float. You could use anything else that you wanted, as long as it's a number value. So a byte, short, int, long, float, or double. And then here we go. Here's our Boolean expression. If grade, whatever you set here, is greater than or equal to 70, you pass the class and it should print a true. So there you go. There's our true. And if we set that to 50, you can see there's our false. So now let's move on to the next one. Now we're going to actually do something with our expressions. We're going to use if and else statements to control the flow of our code. So if and else statements are used to control the path of the execution in your code. It executes a block of code wrapped in braces, as you can see here. You got your braces there. So if this expression evaluates to true, you have your if block. If it doesn't evaluate to true, it drops into the else block. So only one of these blocks will be executed on any in any run of the code. You can also see here that in flowcharts, like we saw before with mine, if statements are represented by a diamond. These are any decision statements. And you'll have an arrow with true written on it, an arrow with false written on it. And then on the true side, you'll just have your expression, the if block, else block on the other one. You can also chain if and else if statements to get 3 or 4 or even more different cases. And we'll play around with that as well. So now let's look at a example. Let's play around with that a little bit. Sorry, let's go here. Now we're going to get rid of this. Go if, whoops, it needs to be lowercase. Let's see, let's set 2 values first. Int num1 equal, here, let's just do it easier. Let's do x and y. X equals 0, int y equals 5. If y is greater than x, we'll print out, whoops, system.out.println y is bigger. And we print that. Oh, we got to add a semicolon there. We run that. Oh, let's try this again. Let's go ahead and run this. There you go. Y is bigger. If we set x to 10, it's not going to do anything. So what it did is it skipped this. This evaluated to a false. Sorry about that. This evaluated to a false, so it skipped this block of code. And now we can see that. So let's go ahead and add an else statement. And let's say system.out.println x is bigger. We go ahead and we can run that. And there we go, x is bigger. So the thing these are things that we can see that we're changing this. Depending on the outcome of this expression, one of these is executed and one of them is skipped. So we can see that. And now let's move on to, let's do something else. One thing that you can see too is these lines of code are almost identical. So we're running this, this multiple times. And that's fine for short things like this. But one thing you want to keep in mind, if you're doing bigger statements and you're doing it multiple times, it's called duplicate code, and we want to avoid that. So one thing you can do in this situation is let's create another variable, which is a string, and we'll learn more about these later. We'll just call that z. And if we do z equals that, and z equals that, then we can print z, and now z will be assigned that value. It'll be printed. So there you go, those are your if statements. Now I want to do something kind of fun in Android. So let's bring up Android Studio. And I want to do something that's a little bit more in depth. It's just like we did in our code the other day with our rainbow assignment. So I want to give you something similar to that. So you can create a new project and follow along with me if you would like, or just create a new project and just watch me do this, and then you can follow along with another one later. Because there is a reason why I didn't have you do it this way. Button color. Let's change this to a button. So yeah, don't worry about following along on this one beyond setting this up. You can go ahead and set this up, and then we can use that again in the next one. In fact, I had to do a couple tests to be able to figure out how to do this. But we'll do it. We'll iterate on this design throughout this module. So we got our button. It's going to be color button or button color. And then we have our constraint layout, because remember right here, that's a constraint layout right there. I call that background. Oh no, whoops. Layout background. Let's line these up. Now let's attach them to our user interface. Our button color. Well, that's not what I wanted. Button color. There it is. We're also going to, let's do this first. Layout. Find view by ID, or.id dot layout. And we're going to update the color of our layout. Set background color, just like you did on Monday. Get resources. Get color. R.id dot not ID color. So used to just typing ID all the time. Primary dark. Okay, so this is fine. If you've written, follow along with this, that's great. We'll add one more thing, and then we'll get to the less than ideal part. Set onClick listener, new review.onClick listener. And now we're going to go ahead and say if, let me just double check, make sure I have everything correct on here. So what I'm doing here is I'm going to I'm checking to see the color that the background is. This is one of the things that's challenging in Android and in platforms like this. This just gets really complicated. So this is saying, okay, our background is a color. I promise you that it's a color, and we're telling it to interpret it as a color. And then we're saying, okay, now let's get that color value. And now we're checking to see if that color value is the same as this. We can just copy and paste this down here. So again, don't worry about following this spot. We'll do it better later on. But it's just kind of a cool thing to see. And then we're going to create an integer value, and we're going to call that color. So this is the target color. So the color we want to change it to. We're not going to give it a value yet. We're going to just say, so this is saying if it's dark, I want you to change target color to be r.id color dot, and we're going to change it to the accent color. Else, so if it is not that color, I want you to change it back to this color. So we'll just say target color equals dot color primary dark. Whoa, I am not getting my arrows right. There we go. Color primary dark. And now down here, we will say layout background dot set background color. Wait a second, let me just move some stuff out of the way. And then we're going to give it our target color. So now what this is going to do is we're setting the color to be the primary dark. And now in here, we're going to check and see, okay, if it is dark, when I click this button, I want you to change the accent color. If it's not dark, I want you to change it to dark. So let's build it and see what happens. Let's run that. Let's bring up the device right here. Building. There you go. It's installing, it's launching. And there you go. So if I click this, it doesn't like that. Let's see why it doesn't like that. Let's use our debug tools. Check that out. Now we'll go into the debug mode. That's what it does here. We'll click this, and there we go. It's dark, so it's going to change to accent. So we should see down here. So what it's doing here is it's running this twice. So we've got to be missing something. That's there, that's good there. Like I said, it's always when you try and demo things to show somebody something cool. Let's do this. Let's try this. I'm going to try something. Whoops. So code there. Another cool thing you can do in Android Studio, Alt-J will highlight multiple, and then we can edit 2 places at once. And then we type that wrong. There we go. Let's just try this. Comment that out. Oh, you know what it was? Because we can just undo all of these things. Okay, the issue that we had is we're not using our get resources, get color. That's what it was. Get color, and then we'll pass it in the target color. So to clarify, this target color is this ID. So we have an ID, and we need to convert that to a color. And they're different integer values. So what we were doing is we were just assigning it to a color, assigning our color to the ID, and that's why we got that weird gray color. I'm surprised it actually worked at all. Just luck that that color pointed to something else. So we can bring this back up. Now it's executed again. There we go. It's going to jump down here, and now it's going to go pink. Click that again. It'll come down here and go back to dark. We can remove that, and we just click these and switch back and forth. So that's something you can do with an if statement. Granted, this is a more complicated if statement, and we're going to go through and make it, clean it up and make it nicer. But first, we're going to make it a little bit more complicated. So one thing I want you to do, now you watch me do that, let's get into Replit, and I want you to write code that will print out which grade a student will receive. So remember, you want to use multiple if statements. Let me do one more thing and show you how to create. Let's see, we have if, we have else, and we want to do one more thing I forgot to touch on, else if, before we have you do that assignment. Y equals, or x equals y. So one thing you can do is you can chain these together. So if you if, else if, and you come down here and you can do else, and this is how you can get multiple statements together. So we can change this. Let's move this down here. Is equal to y. There we go. We'll run that. And now it'll step through and do only one of these three. This is what I want you to do for that challenge. You only have to just do 3 or 4 different grades, and we will go back and show you how that's done. So go ahead and work on that now. I'll give you 2 to 3 minutes on that, and then we'll step out and see how you did. I'll even leave this up to give you a hint. It's got about a minute and a half left. Okay, down to 30 seconds. Okay, so this is my solution. It will likely look different from yours. So you can see how I chained these together. So if the grade is greater than 90, the student got an A. It's greater than 80, they got a B. It's greater than 70, they got a C. And otherwise, it's failed. Generally, you will want to have an else, just a standard else at the end of your if-else chain, just to drop through and make sure everything's caught and you handle all cases. So we can see here, the student failed. If the student got 100, student got an A. And there we go. So now let's move on to something else along the same lines. So we got that challenge. Now a switch statement. This makes if-else chains a lot easier to do. However, there are a couple of caveats. So first, switch statements can replace large chains of if-else statements. It lets you choose between multiple blocks of code, and it executes a block of code based on a case. And you can see here there's a case and it executes this block. So if number matches this, it executes. Number matches this. So you can see you're limited in your Boolean expressions you can have. In fact, that you don't put a Boolean expression, it just says based on this value. So you're limited in there. You're also, these cases have to be constant values. They're not something that you can change or set as like a variable or anything else like that. They have to be constants. And you also can't do a range. You can only do a single value. There are ways to do ranges, but they're really hacky and you shouldn't do them. If you have to do a range, you should go to if-else statements. So now I want to show you them in Replit, and then we'll do something else in Android. So let's do this here. So we're going to do, actually we can, we'll just do int grade equals, oh no, let's not do, yeah, sure, what the heck. This time let's just do single values. So we'll do 1 through 10 because that'll make it easier. And then I'll show you how to do something a bit more complicated to kind of trick this switch statement. So if you do switch, grade, you braces, you also will notice as I type this, and follow along with me. Sorry, I keep forgetting to mention that sometimes. Let's actually just do a 10. Okay, I gave you time to catch up. System.out.println, and we'll just do the grade to save on time. A plus break. So you notice here that we don't have braces inside the case. It works differently than a standard block of code. What it does is it executes, it will, depending on the value here, it jumps to the correct case. Then it executes all the lines of code underneath that case until it reaches the break, and then it will exit outside of these braces. So let's do another one so we can see that. Case 9, system.out.println. And you might not have noticed, but see how these indentations are going? I haven't mentioned that. It's standard in code for you to indent code that is in a separate brace or separate block. So you see here, you have your case, your switch, and then you have a case statement, which is separate, and then inside of that case statements here. So that's the way you nest code visually. And let's bring up my solution from the other one. You can see here your if, since these are all, they will execute at the same effective level. You're never going to have anything, you're not having any of these kind of nested inside. They're all parallel. So you have your if, and it has its braces here that line up. And then so you can easily look at this and see, okay, only one of these is going to execute because I have if, and then they're all on the same level here. So let's get back to this. We'll continue with we'll add our break, and then we'll add one more case, case 8, system.out.println, printing a B, break. So you can have multiple lines here, but it will execute until you reach the break. Generally, though, you want to keep your your cases in your switch statement as short as possible, because the more lines you have, the more difficult it is to read and the more unclear it is. Also, you want to make them be as similar as you can. Generally, you can't make them exactly the same, but switch statements are generally used to do similar things, just slightly differently. And then you do default, and then we go system.out.println, and we'll just do fail. And then the default doesn't need to break because it's the last one. So we've run this. There we go. We got an A. If we set that to 10, there we go. We'll get an A plus. So this isn't very useful, having just 10 points. So it's only a 9 out of 10 system. Let's try something else. Remember what we did in your exercises yesterday when you were playing with the difference between integer division and float division? We've declared this an int. One thing we can do, and think about this, think about what you did, what happened when you divided 5 by 2. You did get 2.5, you got 2.0. And in fact, that was only because you stored it as a float. If you would have stored it as an int, it would just be 2. So if we do grades divided by 10, what this is effectively going to do is it's going to divide whatever grade we have here by 10, and it's going to drop the fractional value. So this is easy because 10 divided by 10 is 10. But what if I get 97 divided by 10? Since these are all ints, this is an int, and then this is an integer expression because we haven't declared a float. It's dropping that 0.7 instead of 9.7. We're just getting 9, and it drops into this case. So you can use tools like this. You can do kind of different expressions and statements in here. You can also manipulate the value outside of here. So if we were to just do int switcher equals grade divided by 10, then we could just use our switcher, fantastic name, to do that, and it's going to do the same thing. So you can do this to kind of manipulate that to massage data into a switchable state. So now let's do something even cooler. We're going to jump into Android Studio, and this time I want you to definitely follow along with me. I'm not going to second guess myself like I did before. We're gonna take this and we're gonna make it run better and be a lot cleaner without all these craziness things here. So let's go ahead and we'll just comment out this block of code. Control Shift, Command Shift / comments out the whole thing. We're gonna add 2 things. In fact, we're gonna add 3 things. We're gonna add an integer. One of them is going to be our color code, and the other one is going to be our number of colors. And I'll show you how we'll use those. So again, hands on keyboard, follow me. If you want, we'll jump back here. Make sure you have added IDs to both of these parameters, and then you have data members for both of them and assign them the values. And then you have your new on-click listener. I'll do this slow to let other people catch up too. So our color code, we're going to assign that to 0. We're going to use this in a switch statement in combination with our increment operator to be able to switch between a series of colors. So here's our code. Now let's come here. We're going to add our target color back in. So int target color, and I won't forget to do it right this time. Yes, that's what we're going to do. We're going to do switch, and our case is going to be our color code. So remember, this is the code. This is going to be the index. In fact, that might even be a better term. Another tool we have is, I'll show you this, Shift F6. You can also right click, let's exit it. So right click, I go down to refactor, I go to rename. Any changes I make here will change all of those, all the states of that. So I do color index. That might be better. So color index, let's fix our there. Now we're going to add our cases. Case, if it's 0, we're going to say target color. It's going to be equal Android.R. So we're getting Android resources, getting color. Hey, look, I didn't type ID this time. So we'll go down here. We'll just do blue bright. We'll return. We'll break. Let's do that again. Shift tab will get you back out. Case 1. Target color equals Android.R.color dot, and we can scroll down just to the next one, hollow blue light. And another, we'll do break this first. Another quick, cool trick is if you highlight a block of code and do Control or Command D, it will duplicate that code. And then we don't have to type it all out again. We can just do 2. We come back here, color dot. We haven't done dark. Let's do blue dark. And here's another trick. So let's do this again. Let me give you a few more seconds, 15 or so seconds to catch up. Okay, let's look here. We're going to delete this really quick because I want to show you the menu. In fact, let's show you another cool trick. If I go here, right click, go to, let's try declaration. There we go. This automatically opens the file, or it will bring your cursor to the place where this was declared. And now you can see these are all the colors that are available to you. Or these are all your hollow colors, I should say. So you have blue light, gray light, green light, red light, blue dark. So you have all these, they're all the same, but they just have this one little thing different. So let's combine some of the things that we've been doing. Let's highlight all 3 of these and Control or Command D to duplicate. We're going to duplicate that. See, it's yelling at us. Switch statements can only have 1 case for each label. So let's go 3, 4, 5, and count. Let's highlight this and do Alt-J to duplicate those. And you just change that to green. And there we go. Doesn't seem to be a green bright. Let's check our colors here. Blue bright and gray bright. Looks like there's no green bright. So we can just change that to gray bright. Or, yeah, let's change that to gray bright. And you can keep doing that. Holy cannoli. Just copy and paste this. Hollow gray bright. Copy. Paste. I swear to you, that's there. Android Studio. Well, let's move on and let's see if we can compile afterwards. Just like you saw the other day, there can be issues with this. Now we have our target color and our color index. Let's do something with our target color. Dot set background color. And then this time I'm not going to forget, get resources dot get color. We're going to give it our target color, our newly assigned target color. Oh, and lastly, one thing we need to do is it's telling us target color might not be initialized. So if our case is anything but 1 through 5, we don't have a default, so it's not going to do anything. So let's fix that. Let's do case. Oh, not case. We're going to do default. Default, and that's going to be target color equals, and we're just going to make that white. R dot color dot white. And there we go. And in fact, we can go here. Control or Command B will get us to there. And here's our colors, our standard colors. And see, these aren't just the hollow colors. So there's a lot of colors you can deal with. These are kind of fun. It would have been fun to play with these. You can see how it does the gradient. So just different, there's a lot of stuff that are provided for you, and you just got to dig into it and see. Let's make sure. Let's try and compile it and see what happens. Oh, last thing, I promise. We need, our color index is static. Our color index is always 0. We're not doing anything with it. What we want to do is we want to increment it. So color index plus plus, there we go. But what happens when we reach 5? In fact, let's find out. Let's debug here. Let's make sure it can execute. It still might not like that gray bright for some reason. Yeah, see, it doesn't like that color. Let's find a different color. Yeah, a really bright gray. Just give it orange dark because I think that orange looks cool. Okay, now it's liking that. In fact, while it's compiling, let's look at that and see why it's not hollow gray bright color name. I think we might have found a bug in the compiler. We'll have to do some research to see what happens there. So now let's bring this up. We have our colors. So now let's go back to our code. Click this. There's our bright blue. There's our light blue. There's our dark blue. There's our dark orange, our light green, our dark green, and our white. I click this here. It's still white. So what's happening? Let's check it out. Let's hit our debug, and we're going to click the button. Our index is now 13. We don't have a case for 13, so it's going to be default. So how can we make our index value loop around? How can we make it not just stick with incrementing? Because otherwise we're just going to stick here with white, and it's just going to keep going and going and going. 14, 15, 16, 17, since I kept clicking this. That's where the modulo operator comes in. And that's one thing that's really cool about modulo, and you'll start using it. Just the modulus function. So in this situation, we are going to have to store the value because we're not just incrementing it. We're going to change that to a pre-increment. And we're going to go modulo color number colors. So what this does, first we need to set our value for number colors. And we have 6 colors. Let's just check. So that's the number of colors that we've provided in our statement. 0 through 5 is 6 colors. And then we have white. So you can make it 7 if you want to show the white. So what this is doing is you have your incrementing your color index and then your modulo number colors. Let's check it out, and then I'll walk you through what it does. Holy cannoli, I'm going quick. I'm going pretty slow. I just get so excited about showing some of these things. And a lot of you probably wish that I would have shown this before, because then you have one button that does everything you needed to do before. Let's do our colors. There you go, all the colors. And then it goes back to blue. So let's check this. Oh, well, let's get it to green first. Orange, light green, green. So I'm going to click it again. So here we go. Our color index is 0. And if we click the button again, it's going to go up to 1. So let's give it a couple more. We got to continue execution. Okay, now let's add it there again. If I click it, color index is 5 because we're incrementing it. So we say, let's just do first 5 modulo 6 is going to be 5 because 5 divided by 6 is 0 with a remainder of 5. But if we increment that, 6 divided by 6 is 1 with a remainder of 0. So with the modular operator, you're dropping the 1, you're dropping the whole number rather than the fraction. Whereas before in our replet here, we're dividing, and that's dropping the fraction. So those are two things you can use to massage data and numbers to do what you want. You use the divisor, the divisor with working with integers to drop a fraction value, a decimal value, and you use the modulo with integers to drop the whole number value. So that allows you to loop things around with modulo and then to chop some stuff off to get some rounded data. It's effectively rounding down a number by whatever you want. So those are some cool things. It was fun kind of playing with that. Let's jump through some of these other ones. There's a lot more, and we're getting close to the end. We're past the end. I'm sorry. Sorry for going long again. I'm just so excited. So Boolean operators. You can use Boolean operators to combine two Boolean expressions. You want to be sure to put these in parentheses to help with your code and readability. Use logic tables are used to track the results of expressions. So for example, and two ampersand symbols. It's true if both sides are true. It's false if either of the sides is false. So we have two expressions. We have expression A and expression B. If they are both true, then this is true. If one is true and one is false, it's false. And all other situations is false. So if either of these is false, it's false. Now, or is true if either side is true. So, and this is either side non-exclusive is what it's called, non-exclusive or. We'll see an exclusive or later. But either or both sides. So A or B is true, true. So you can see here, it's the opposite, almost, not quite. But these are three falses and a true, three trues and a false. So you can use these to combine them and get more complex logic. So yeah, I see now here too, a not is the opposite. It will invert the result of the expression. Like we saw with not equals, it can do that on any Boolean expression. So if A is true, the result's false. If A is false, the result's true. So we'll do this a couple of times, then we'll move on to the next part. So let's go here. So now we can say int complete assignments equals bool. Let's make this a Boolean. Equals true. So now in order to get an A, you have to have your grade greater than or equal to 90, and you have to have completed all your assignments. And so now we'll copy and paste this down. So if you don't complete your assignments, you're gonna fail. In fact, yeah, so let's try that, and we'll do one more thing, and then we'll jump back into loops. So there you go. The student got an A because they completed their assignments. False. They failed because they didn't complete their assignments. So you have to complete the assignments to pass. What if it's an or? What if it says, oh, well, you know what? You can do really great in your assignments, or you can do really great on the class, or you can complete all your assignments. So if we run that, even though this is false, it evaluates to true because it's an or. So there's that. Let's go on and we'll touch on some loops. Or first, ternary operators. So a ternary operator allows us to simplify code and avoid repetition. So it can combine 4 or 5 lines of code into a single line of code. There are a couple of caveats with this as well. You can be used if both blocks return a value to the same place, or if they perform the same task like this. So up here, we're printing both of these. So instead of doing an if on the outside, we can do a ternary on the inside, and it'll do true or false. The same thing here. With a value, we're returning the value to a number. So this will be returning this to the number. So let's see that in action. Right here. So let's go back to a pass-fail system. Let's see. That's our switch statement. Okay. Let's go back here. to a pass-fail system. So we have a grade, and we'll do system.out.println, and we're going to do our grade. We're just going to say our grade is greater than or equal to 60. And then you have your question mark telling you that that's a query, or it's a Boolean expression, an if statement. And then we're going to just say passed, colon, failed. So what this is doing is saying if the grade is greater than or equal to 60, I'm going to return passed. If I don't, I'm going to return failed. So we run that. You can see it passed. If you do 50, we run that. You can see it failed. And you can do that with, you don't have to do that with the statement here. If we wanted to just say, again, with the example from before, 1 or 0, int result equals, and then system.out.println, and I'm printing it so that we can see, because in this tool we don't have a lot of ways to view values. Oh, it's because I spelled it wrong. Getting anxious. There we go, 0. And then if we bump that up to something 80. So ternary operator is a way to compress certain expressions into a single line of code. It makes it easier to read, it takes up less space, and as long as they're simple, you see that I didn't do anything complicated in there. So now we got 2 more objectives, and then I will let you free. So now we are going to use a while loop to run code until a condition is met. So here we have 2 different types of while loop. You have the while loop, which enters a loop if the expression is true and exits the loop when the expression comes false. So if this value is true, it will come here and enter it, execute, then it'll go back to the top, check if this is true again, and execute, and go through that loop until this becomes false. If this is false at the beginning, if I set value to false out here, it won't ever enter and it'll just leave. That's where the do while loop comes in handy. If value is false, it'll come in here, do this thing once, check. If value is false, it leaves. If value is true, it'll just loop back around again. So it's just a different place to put your check. So let's do that. We'll do that together here. And I'll start clear so you don't have to do anything. And what we're gonna do is we're gonna print a bunch of numbers. We're gonna say int counter equals 0. Then we're gonna say, remember, follow along with me, while counter is less than or equal to 100, I want you to just system.out.println counter. So it's just gonna, this is gonna effectively, it's gonna count up from 0 to 100. We click that. We execute it. Oh, I apologize. This is what's called an infinite loop, because what did we miss? Give you a second. We didn't increment it. So we're saying while counter is less than 100 and counter is always going to be 0. That's not very helpful, and we'll get stuck there forever. And good thing we have an output, otherwise it would just be sitting there and we wouldn't know what's going on. So that's one thing you want to definitely be close to. There you go, counted to 100. Now if the value is 1000, you can see it doesn't print anything at all. Let's try that with a do while. So if we do, and then come down here, while counter is less than or equal to 100, we add a semicolon at the end. And we're going to run that. And remember, we have our increment. So it did 1,000 and it incremented it, but it's no longer less than 100. It never was less than 100, so it just printed it once. So now let's look for one last thing. And this is going to be a for loop. We use a for loop to perform a task a specific number of times. It is the most common loop that you'll use, and the number of loops have to be set upon entry. Unlike the while loop, that it depends on the state after the loop has been executed or before the loop has been executed. This says, okay, I'm going to run it a certain number of times. So let's see that. So let's leave our do while loop up here. In fact, we'll comment it out so we can see it and we can compare it later. So follow along. We'll do for int I equals 0. So there are 3 parts to a for loop. First, you declare your iterator, is what it's called. And that's going to tell us, okay, that's our counter. That's going to tell us point where we're at. Then you have I is less than or equal to 100. And that's going to tell us this is effectively the same thing as right here. This is what's checked at the end of every loop. And then we have plus plus I. And so this is what's telling us this is our counter. So we're incrementing our counter. So what happens here is at the very beginning, one time it'll set the value of I to 0. At the end of every loop, it will check to see if I is less than or equal to 100, and it will increment it. So let's do system.out.println, and we're going to print I because we have access to I here. You run. Now you notice we did I instead of counter. Because this is a standard format, for loops are generally used just a single letter. And it's usually I or N or something like that to declare it because it's inside of this loop. We know what it's used for, and that's exactly what it's going for. So there we go. It counted through that, and you can compare 4 lines to 2 lines in a brace. And that's how you can use for loops, and that's a benefit to that. There we go. We plowed through everything. Those demos took a little bit longer than I thought, but I thought they looked cool and they were kind of fun to do and to see. So let's check out the assignment really quick, and then you shall be free. So again, we're going to complete the intro to Java assignment, and we're going to bring that up right now. There, that one. So here's our assignment. This is a 2-parter. You have the code that's found in your classroom right here. Same as last night, except we'll just do 3 simple things. You're going to write a while loop that counts from 0 to n. For loop that's 0 to n, inclusive. Make sure you're printing n as well. And then if else. I want you to print the value of whatever is greater. So if x is greater, I want you to print x. If y is greater, I want you to print y. So you know, that's simple. The next part is a Google form. So you have your link here, and then you got to answer all of these questions. This is where you're going to flex your logic muscles. So you can see here you have an expression. X is equivalent to y. And then you have your values. If x is equal to 0 and y has the value of 1,000, does this expression evaluate to true or to false? And you have that with 3 different values on all these different expressions. It should be pretty quick once you get kind of the hang of it and the way that it's formatted. So go to the next page, and this one are truth tables. You do something similar. And again, this is really quick. Once you sit down and think of the logic first, you can easily step through it. And you've already seen some of these. I still want you to puzzle through it if you can. Don't go back to the video or to the slides to be able to see that. Just sit there and look, okay, X or Y. If X or Y is true, A, B, C, or D. So it's A true, B true, C true, D true. And you do that with all these. Exclusive OR is what I was hinting at before. This is exclusively X or Y. So if it's both, it's a false. Whereas up here, both is true. Then you have X, Y, and Z. What happens? You have 3 variables. And there you go. So we'll go through and you'll do all those. And then when you're ready to go, you click submit. It'll send that to me. Again, thank you guys all for sticking with it. I'm sorry we went a few minutes over. I appreciate your time. I will be keeping an eye on the Slack channel. Contact your PMs if you have any questions, or message me as well. And again, I appreciate your time and thanks for sticking with it. I'm excited to go into this is our last Replit assignment. Tomorrow we'll build a fun little game that you'll be able to build in Android and play around with that. Thanks again and good luck.